elucidate new mechanisms,
boldly catalyze transformation.
Chemistry. The solvent frontier. These are the voyages of the Primary Synthesis Laboratory on board the USS Erlenmeyer, flagship of the Chemical Federation, alongside the vacuum-class filtration ship SS Buchner. Our continuing mission to explore new reagents, to educate and elucidate those preparative pathways that lead to the prime derivative, seeking to condense knowledge to boldly precipitate a compound interest, an interest in compounds like YouTube has never seen.
Chemist's log. Stardate 9012-026.
SS Erlenmeyer, this is the Buchner. We received your distress call. The signal is poor, so I hope you can hear me. What seems to be the problem, Admiral?
The Erlenmeyer is currently navigating the perimeter of the Anhydrite Nebula.
Stand by.
We were conducting a routine mineral survey on the surface of Catalyst 4 when a sudden surge of ionized gas hit our transporter beam. The interference didn't just scramble the signal, it acted as a molecular sieve. My Chief Science Officer, Lieutenant Aris, reports that the away team has rematerialized in a simplified state. They are currently sitting on the transporter pads as 4 distinct mounds of para-aminobenzoic acid. Their quantum signatures are trapped inside a white crystalline powder. Without their carboxyl groups, they lack the organic complexity to sustain life. We have rendezvoused with the USS Petrie. Their commanding officer, Commander Vane, is holding the key to their survival. He has managed to stabilize a sample of the crew's remains in a specialized containment flask, and we are about to attempt a high-risk decarboxylation. If we can trigger the transition to an aniline base, we might be able to resequence their DNA. If not, the crew of the Erlenmeyer will remain a chemical curiosity forever.
Message received. We await your instruction.
And boldly catalyze transformation.
That have never been seen before.
Para-aminobenzoic acid.
Never been seen.
Which we'll call PABA from now on, can be purchased in its pure form as a health supplement. Either the raw powder, if you can find it, or in this case as capsules. It is found naturally in several types of food, from yeast and molasses to mushrooms and leafy greens. It is also in dairy produce and in organ meats such as liver and kidney. Whether vegetarian or not, a balanced diet should ensure you have a healthy amount of PABA. It's very unlikely for anyone to be PABA deficient. It used to be classified as the essential vitamin B10, until scientists discovered that our bodies don't use it the same way that bacteria does. Its main biological role in bacteria is for the production of folate, or folic acid. The enzyme
dihydroxyapatite synthase
has a dedicated slot that PABA fits into like a key. There is an antibiotic that mimics this molecule called sulfanilamide. This works through competitive inhibition. The oxygens in the sulfonamide group, the sulfonyl oxygens, create similar electronic signatures to the oxygens in the carboxylic acid group of PABA. This sulfur group is not for show. It acts as a wrong key in the lock. Sulfur-oxygen bonds are also very stable, forming strong hydrogen bonds, making it stay attached to the enzyme. When this happens throughout the bacteria, it is a metabolic dead end. The sulfur group makes the molecule slightly acidic, which helps it to remain soluble in the body, so it can reach bacterial infection and do its mimicry magic. It's also ideal for attaching side chains, which is how we get our modern sulfur drugs, by removing a hydrogen from the amine part of the sulfur group. The enzyme latches on thinking it's a PABA molecule, and while it has this attached, it is unable to produce folate. Without folate, it's unable to produce DNA. It's unable to replicate. So eventually the colony dies. Because we don't produce folic acid ourselves, the sulfur drug kills off the bacteria while causing you no harm. An example of selective toxicity. Selective.
Before taking antibiotics, consult your doctor.
Now then, we can start by charging a round bottom flask with our PABA. We can discard the capsules. I weighed this glassware beforehand. That was about 200 grams. So we can deduce that we have about 56.5 grams of para-aminobenzoic acid. We want the heating mantle set quite high, like 200 degrees. The reaction tends to proceed in the molten state, so we want it to melt. Removing the aniline via distillation helps drive the reaction forward. For a higher yield, a high boiling solvent like cyclohexanol can be used, alongside an acid or base to catalyze. But since this is just the away team, it doesn't really matter. A bit of charring and a bit of product loss, neither here or there. You won't really notice. It definitely looks molten, and we seem to have gas evolution. These are all good signs. Oh, it appears to be boiling whatever I was using for a heat transfer in the thermometer well.